Today we are going to discuss a new tool, sensitivity analysis. Now this is a tool that can be relevant to many different analyses options, not just risk analysis. It can be useful in life cycle assessment, benefit cost analysis, and in many different situations. Sensitivity analysis is a way of looking at the uncertainty around a variable and how that uncertainty impacts the results, the outcomes. So this takes us back to variables. And the definition of a variable is a parameter that can vary in value. Very variable, right? So the value of a variable or an estimate is required to conduct the analysis. Our variables vary. That means they have some uncertainty around them, right? So here I've given you a math equation. Actually, this is for fluid dynamics. But in math, we have these equations that have variables, and each variable needs a value to determine the result, the outcome, right? So in this equation, this is Manning's equation for open channel flow. You don't need to know that, but we've got a number of variables here. Our outcome variable, V velocity. Our N, which is a Manning's roughness coefficient. R is another variable. This is our hydraulic radius. And S stands for slope, is the variable for slope of the channel. Each of these variables has some variance, some variability, some uncertainty around them. For example, S, slope, we usually measure that for Manning's equation using some GIS, some total station laser to get the slope of the channel. And each piece of equipment that we use has a plus or minus value with it, right? It has the degree at which it can measure accurately. So there's some uncertainty around that final number. It might be very, very small if we're using a total station to measure slope. Our variance, our uncertainty might be a very, very small number, but there's still some uncertainty. Likewise, for hydraulic radius, the tools that we use to measure that, whether it be a measuring tape in our eyes or some survey equipment, they have some uncertainty or some wiggle room, some error within them. N is the same way. N is something that you have to look up using pictures and books. So this is probably the variable with the most uncertainty. Now the uncertainty around N, R, and S are all captured in our final answer. We have an outcome, but there's quite a bit more uncertainty around the outcome, the value, than there were around each individual variable. So our sensitivity analysis then compares that uncertainty, the variance associated with each variable, and how that uncertainty relates to variance in the output, in our result. Our sensitivity analysis seeks to determine which of those variables or parameters matter the most in an analysis. And it answers the question, what makes a difference in this decision? In that equation back there, my N, R, and S, which of these variables really makes the biggest difference in my V, my outcome value? Here we have an example of a fairly simple sensitivity analysis. We looked at the life cycle costs of two different washing machines, a traditional top loading and a front loading one, the front loading being more energy efficient and water efficient. And we found that machine 2, the energy efficient one, was $250 less expensive than machine 1 over the lifetime. Now this analysis was done with today's water prices. So we asked, well, if the price of water changes in future years, will machine 2 still be a better buy? We took one variable, that was the price of water, and we calculated what would occur with the costs of the different washing machines if our one variable, price of water, varied over time or varied at all. And we saw as our price of water increased, so we are currently at $2 per 1,000 gallons. As that price goes up, machine 2 would still be a better buy over the lifetime of the machine. So at $2 per 1,000 gallons of water, we're looking at approximately a $250 difference between the two machines, with machine 2 being the better buy. And as water increases, our price difference, our cost difference over the lifetime increases as well. Similarly, we saw that as the cost decreased, the price difference decreases as well. But even if we get to, 25 cents per 1,000 gallons. So even if the cost of water decreased all the way down to 25 cents per 1,000 gallons, machine 2 would still be a better buy. We're still in positive values over the lifetime of the two machines. So this is an example of how there was many different variables that go into the life cycle costs of these washing machines. And we just looked at changing one. So the sensitivity of our outcome, our price difference, to changes in one of the variables. Our price of water was the variable that we looked at. This is a very simple sensitivity analysis, but it was effective.